Question 16. A sound wave passes through the air in the direction showing. How does a particle of air move as the sound wave passes? Sound is a longitudinal wave, which means the particles in the air is going to move back and forth. So like this, no, that's not correct. This is going with the same direction. It's like the particles in the air is moving with the wave, and this is not correct. So this is false. The second option, move left and right. Yes, the particles all the time vibrate back and forth and disturb the next particle, which disturb the next particle. So that's how the energy is being carried through the motion. So that is correct. Up and down, no, there will not be up and down because sound wave is a longitudinal wave. So this is false and this is false. So the right answer is B. Question 17. Water waves change direction when they move from shallow to deep water. What is the name of this effect? So now we have from shallow to deep. So this is called refraction of water. Every time a wave change direction because this is slowing down or speeding up, so that is a refraction property. So here you'll be refraction. Question 18. The diagram below represents a wave. What is the speed of the wave if its frequency is 8 Hertz? So the best way to answer this question is using the speed of a wave formula, which is equal to the product of its wavelength times frequency. So frequency was given, but the wavelength is not directly given. We have to look at this graph. So here we have the length of 3 cycles, 1, 2, 3. So it's safe to say that one complete cycle has 2 meters. Like this distance here is 2 meters, which is the length of this wave or wavelength. 2. This one here is 2. And the last one is 2. So 2 plus 2 plus 2 is 6. Okay, so now that we know the value of the wavelength, which is 2 meters times the frequency, which is 8 Hertz. So 2 times 8 is 16 meters per second. So that's the answer, B. Look at this beautiful picture. So radio wave, this is question 19. Radio waves are received at a house at the bottom of a hill. The waves reach the house because the hill has caused them to bend, right? So this is caused by diffraction. So it's being diffracted. So thanks for this property, we can receive radio waves and microwave signals for our cell phone and other types of telecommunication. Question 20. The diagram shows a ray of light entering a block of glass. Which numbered angles are the angles of incidence and of refraction? So the incident angle is the angle that the ray makes with the normal, which is 2. And the refracted angle is the angle that the refracted ray makes with the normal. So here is 2 and this is 4. So the option is D. Question 21. Which diagram correctly shows a ray of light passing through a rectangular glass block? So here we have 4 options. So the ray is coming from, let's assume, air to the block, back to the air. So all options go like this. I want to start by eliminating option D. Option D here, there is no refraction from the air to the block. So this is not correct. So let's take a look on the other options A, B. Another one that I want to work with is option B. So if this air and this air is doesn't look right, that I know that the ray is going to refract away from the normal, but this is kind too much. So compare with the angle of incidence here. So this picture is not correct. So I'm going to eliminate these two. Now let me see who is the winner here. Let me work with you with option C. So if I draw a normal line here, and I draw a normal line here, let's analyze one thing. So this is the incident angle, and this is the refracted angle. Doesn't look right. Why? Because it's refracting to a more dense medium. So the angle here should be less than the incident angle. So let me call this incident, and this is refracted. So the correct is when the incident angle is greater than the refracted angle, because it's coming from a less dense median to more dense median. So C is eliminated. So the correct answer is A, because right here, if you draw a normal line, it's very tiny, hard to see this, but for all these options, this is the best one, because the angle here of refraction is slightly less than the incident angle. So the correct answer is A. Question 22. The speed of light with this frequency in a transparent material is 0.75 times its speed in the air. The absolute index of refraction of the material is approximately. So I'm going to use the formula here, N is equal C over V. Now remember, C is the speed of the light in the air or in the vacuum. And V is the speed of the light in the medium. Okay, so the C here, I will keep C like it is. I could replace with 3 times 10 to the 8, but the option here is not going to work this out. So let's hang there. So there will be C, but the speed of the light in the material is like 75% of the speed of light in the air, or 0.75. So we can write it this way, 0.75 C times C. So we cancel C, and N is 1 over 0.75. So now, let's use our calculator here. So 1 divided by 0.75 is 1.33. So 1.33. So the best option is B. Question 23. Music is produced by the loudspeaker of a radio. Which property of the sound wave increases when the music is made louder? Here we're talking about volume. So volume is tuned up. So what is change of the wave? It's amplitude. Now the amplitude, this is, let's say, for a lower volume, and a higher volume, you have a greater amplitude. So the amplitude is the feature of a wave, of a sound wave, that is going to change the volume. Question 24. 2 identical circular waves, A and B, overlap and intersect as shown in the picture below. The darker circular lines are the crests, so crest, 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 and the lighter circular lines are the troughs. So between 2 crests, we have the troughs. So which point P, Q, R, or S indicates constructive interference between waves A and B? So constructive interference is when crest intersect with crest of the water wave, or trough intersects with the trough of the other wave. I'm kind of gagging here. Now, destructive interference is when the crest intersects with the trough. So that's destructive. So we are looking points on the graph provided in your exam that shows constructive interference. So for construction, constructive, crest with crest, like full line, like the one that is like darker. Or trough with trough. So crest with crest or trough with trough. Those intersection means constructive interference. So let's see. So here we have crest with trough. No. We have here this P, crest with crest. Yes. What about Q? Q is in the middle, so it's not even intersecting. B here is just on the crest. It's not the intersection there. And S, there is no intersection. They are just kind of side by side. They are not kind of overlapping. So there is a overlapping that needs to occur in order to have constructive interference. So the option is P or A. Question 25. The diagrams show examples of wave motion. This is the ripple tank. This is a drum. This is waves on a rope. And this is wave in a spring. Which are longitudinal waves? Okay, so number one, sound waves are longitudinal waves. So that's for sure. So wave in the air. So for sure is true. Now let's look. Now this here, the particles go up and down. So that's not a longitudinal wave. This here, the particles kind of move outward. This is not a longitudinal wave. But this one here, the particles on the slinky moves back and forth. Not the particles, but the coils in the spring. If you move, it's going to move it back. Let's see if I can do this. So this is the slinky. So you see, as the particles kind of back and forth, let that darker section. So this is an example of also longitudinal. So the option here is 2 and 4, which is D. Question 26. The diagrams show the wave patterns of 4 sounds shown on a cathode ray oscilloscope, or CRO, just like a display. The oscilloscope controls are set at the same for each sound. Which sound has the highest pitch? So pitch is frequency. So pitch is how you hear the frequency. So by definition, frequency is the number of cycles per second. So it's like what is the option that gives me the most amount of cycles? So should be option A. We have way many cycles than B, C, or D. D, we have just one cycle. So that has the lowest frequency or the lowest pitch. So it's looking for the highest pitch or higher frequency. 27. A tuning fork is marked with the number 320. This indicates the size of the frequency. What does this mean? Let's go to true or false for each statement. A, the length of the tuning fork is 320 millimeter. You and I know this is not correct, so this is false. B, the note from the tuning fork will last up to 320 seconds. Never heard about, have you? C, the sound waves produced by the tuning fork travels at 320 meters per second. No, this is not the speed. But what it is the number of vibration the tuning fork produces when is in acting, right? So it's vibrating here, the tunes, tinies, vibrates 320 times every second. So that's the right answer. This is the frequency. So 320 here is the frequency of a tuning. Question 28. The diagrams represent the waves produced by 4 sources of sound. The scales are the same for all the diagrams. Which sound has the highest frequency? So this is very similar with question 26. So the highest frequency will be the one that have more cycle for that space. So here is saying that they are all at the same scale. So the one that fit more cycles for that particular space is D. Question 29. The frequency of a musical note is increased. A student hearing the sound detects an increase in which property? Loudness of the sound, pitch of the sound, speed of the sound, or wavelength of the sound wave. Pitch is the audible frequency, so that is the answer. Loudness got to do with the amplitude. Speed of the sound wave is nothing to do how you hear a frequency. And the wavelength is not going to determine that how you perceive, how you hear a musical note. Is just the pitch. Question 30. Which row states two properties of sound wave? Sound wave is a longitudinal wave and a mechanical wave, which means, number one, mechanical need a media to propagate. Longitudinal is because the particles in the medium moves back and forth. So, can travel in a vacuum? No, cannot. Can travel through water? Yes. Sound can travel through water. Just you can be submerged and say something, someone you hear a something, but not exactly what you want to say, but something will be propagated. And sound is a longitudinal wave, so this is C. Last question. Let's read. Question 31. A wave is diffracted as it passes through an opening in a barrier. The amount of diffraction that the wave undergoes depends on both amplitude and frequency of the incident wave. Let me do a little bit different here. I'm going to bring back this picture. So as you see, the amount of the diffraction the wave undergoes will depend on the size of the wavelength and the size of the gap. Not amplitude, not frequency, nothing else. Just the size of the wavelength and the size of the opening. Which is the best match is option C. Depends on the wavelength of the incident wave and the size of the opening.